Ampere-Maxwell law we're going to look at, and shortly after Ørsted had discovered that electricity can cause magnetism, within a week Ampere had started to quantify those values, and he discovered that if there's a certain current flowing through a wire, there is a magnetic field that is around that wire, and that field direction would be notated by the first right-hand rule. So your thumb in the direction of the current, your fingers would curl in the direction of the field and go around the wire like that. And he found that that enclosed current in that loop is proportional to the magnetic field that is given off that's spread out over that loop. So this integral is a surface integral. The B and the dl are both in the same direction, but the B is not dependent upon the dl, so it can get pulled out of the integral, and then that just becomes the surface integral of the circle, which is going to be your circumference. And so that's how he quantified that value. Well, along comes Maxwell, and he says, that's all well and good, but if I throw a capacitor into this circuit, then I'm still going to get a magnetic field around this wire, so I'm going to have to adjust this Amperian loop to include part of that part that's in the capacitor. But it isn't the current any longer that is causing that, so what would that be? And he discovered that it is the electric field that's causing the magnetic field from that. And so he was able to turn that into a quantified value and equation that he discovered that is this sort of the flux idea, the electric field flux that's going through that Amperian surface or that Amperian loop. So then when you put those together, you end up with the Ampere-Maxwell law. So we have the magnetic field, the surface integral of the length, is equal to the Ampere's part that has the current plus the Maxwell part that is the electric field. And then when we pull out that mu value, you end up with the Ampere-Maxwell law. Now, this is very similar to something that we studied earlier in the year. It's similar to Gauss's law. Gauss's law shows that the electric charge is proportional to the electric field flux through a Gaussian surface. And the Ampere law, Maxwell law, shows that the magnetic field is proportional to the electric current flowing through an Amperian loop. Now, keep in mind that the Gaussian surface is going to be three-dimensional, and the Amperian loop is just going to be two-dimensional. It's going to be the spread out over that surface that you're looking at. They both deal with fields, and they both deal with the proportionality with whatever it is that they're looking at. So that, in a nutshell, is the Ampere-Maxwell law.